Hello, and welcome to the Data ONTAP Data Protection and Retention Part 2 module for the update to Data ONTAP Release 7.3. By the end of this module, you'll be able to explain the benefit of deploying SnapVault primary and secondary on the same system. Also be able to explain how Qtree, SnapMirror, and SnapVault scalability have been enhanced. And you'll be able to describe how a LUN connection is preserved during SnapVault restore. Also, we'll be able to explain the SnapVault backup LUN clone process. Now in Data ONTAP 7.3, you'll be able to install both the SnapVault primary SV_ONTAP_PRI and the SnapVault secondary license SV_ONTAP_SEC on the same storage controller. This system is then able to send and receive SnapVault backups, whether that is between storage controllers or locally within itself. Note that you cannot mix primary and secondary Qtrees in the same volume, as this is not supported and can cause undesirable effects. Also in Data ONTAP 7.3, Qtree SnapMirror, QSM, and SnapVault are both re-architected to increase the maximum number of concurrent transfers, and that is up to 16 times on certain platforms. This allows for better utilization of the backup window. You want to refer to your Data ONTAP online data protection and backup and recovery guides in order to see these new values. In Data ONTAP 7.3, performance has also been increased. The new QSM architecture shows significant improvements over the legacy QSM or SnapVault for various popular data sets. We achieve over 2 times throughput improvement as more scheduled transfers can be run in parallel. Note that the maximum entries in the snapmirror.conf file remains at 712. In 7.3, a new Data ONTAP option has been introduced that will allow you to change between the new and the legacy QSM architecture. This option is option replication.logical.transfer_limits, and it'll be either previous or current. The default value will be current. When the previous value is set, the maximum Data ONTAP 7.2.0 values are then used. The value can be changed only when there are no active transfers going on. Another new Data ONTAP option has been introduced that lets the user specify the number of QSM or SnapVault transfers for which they want resources reserved. At the system prompt, you would type options replication.logical.reserved_transfers and then specify a number. The number would be the number of QSM or SnapVault transfers for which the resources should be reserved. The default value of this will be 0. What this option guarantees is that a specified number of QSM and SnapVault source and destination transfers can always be started based on the reservation. There are some performance impacts when dealing with active-active configurations. And the main 2 areas of concern are that in an active-active configuration, due to system load when many transfers are running in parallel, the takeover may exceed the maximum allowed time. Also, client traffic latency may increase when multiple transfers are running in parallel due to increased system load. You can always use the perstat and systat commands to identify the performance regression. The current SnapVault restore supports only baseline restores to a non-existing primary Qtree. All Qtree contents are transferred from the secondary back to the primary. Snap Vault Restore does not allow you to restore a small part of the original data set. Snap Vault Restores don't allow restore of data in place. The primary Q tree has to be deleted prior to performing the Snap Vault Restore. A Snap Vault Restore is going to be disruptive for applications using LUNs, such as Snap Manager for Microsoft Exchange. In this case, the unusable LUNs have to be disconnected, and the primary Q tree containing unusable LUNs must be deleted before the restore. When the restore is complete, the applications have to reconnect to the LUNs in the newly restored Q trees. Disconnecting and reconnecting the LUNs results in drive letter changes and requires that applications be reconfigured. So here are the restore enhancements. In Data ONTAP 7.3, Snap Vault is enhanced in order to restore data to existing primary Q trees. This is achieved by the implementation of new Snap Vault baseline in place restore feature. Also within Data ONTAP 7.3, you can restore a primary Q tree to a chosen backed up version on the secondary. In other words, you can perform a Snap Vault incremental restore. These enhancements allow you to restore data in a non-disruptive way for data sets containing LUNs. This is how in-place restore works. Snap Vault baseline in-place restore accepts the existing primary Q tree to restore to via the following process. Step 1, primary Q tree contents are cleaned up. Then step 2, once the primary Q tree is empty, it is captured in a snapshot copy and exported. Step 3, then the baseline Snap Vault restore is initiated. All of the Q tree contents are transferred from the secondary to the primary. And 4, when the transfer is complete, the primary Q tree is made write enabled. This is an example of an in-place restore. To protect from accidentally overwriting the primary Q tree data, the user will be prompted for confirmation. The command at the primary storage controller would be snap vault restore -S, then specify the secondary : the /vol/ the volume name / the secondary Q tree, space, then /vol the volume name / the primary Q tree. And it will say the restore will overwrite existing data in that vol / volume name primary Q tree. Are you sure you want to continue? And you would say yes or no. You can use the -F flag to override this confirmation prompt and directly proceed with the restore. And this is how incremental restores work. Snap Vault incremental restore also accepts the existing primary Q tree to restore to. Incremental restore is based on Q tree snap mirror, QSM, resync style